Hey everybody, here are the notes for section 4.3. 4.3 is about greatest common divisor and least common multiple, which you have had experience with. So some of this will be familiar, and then there's a couple of new strategies for both finding and using both of those things in that section or in this section. So we'll work through them. First, we're going to start with greatest common factor. So the greatest common factor, or you'll find it called the greatest common divisor too, of two whole numbers a and b, and then both of which are not zero, is the greatest number that divides into both of them. Okay, so there's a couple of different methods. All right, so first is prime factorization. So what you're going to do is write each of the prime numbers as a product of its prime factors. Okay, you're going to do the prime factorization. Then you're going to list the prime factors, okay, with the smallest exponent that appears in each prime factorization. That is the product of the prime numbers, or sorry, the product of the prime numbers is the greatest common factor. So bear with me. Okay, so let's just find, before we do the prime factorization method, let's find the greatest common factor of 36 and 24 any way you like. For me, you just think about the factors, right? So if I have 36 and I have 24, I think about the things I multiply, right? I got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, okay? For 24, I've got 1 and 24, I've got 2 and 12, got 3 and 8, 4 and 6, okay? And then we look at our list. Well, what's the biggest number on the list that both have? Looks to me it's 12, right? So we know going in the greatest common factor is 12. So let's try the prime factorization method. So I'm going to have 36 and I'm going to have 24. So let's break up 36. I'm going to make it 9 and 4, 3 and 3, 2 and 2. All right, so that makes the prime factorization of 36 2 squared, 3 squared. All right, let's do 24. 6 and 4, that's 3 and 2, that's 2 and 2. All right, so I have 3 to the first and 2 cubed. All right, so what it said was list the prime factors with the smallest exponent that appear in each of the prime factorizations. So what we do is we look at the kinds of numbers in here. We have 2s and 3s, we have 2s and 3s. All right, so I know I'm going to need to use a 2 in my prime factorization, in my greatest common factor, and a 3. And then I look at both sides, and I look for the smallest exponent. Well, this is a 2 squared, this is a 2 cubed, so I'm going to use 2 squared. This is a 3 squared, and this is a 3 to the first. I'm going to use 3 to the first. Okay, so 2 squared is 4, times 3 is 12. Interesting, right? That's how you do it. So this is one way, okay? The second way is with a Venn diagram. Now, this is not, this is okay if the numbers are pretty small, right? If the numbers get bigger, this gets kind of ugly. So draw a Venn diagram with the elements of each set are the factors of the two numbers. Look at the elements that are in the intersection, and the greatest common factor is the biggest one. So if we draw our circles for 36 and 24. All right, let's make this one 36. Let's make this one 24. They both had a 1, right? They both had a 2. They both had a 3. That guy had a 36 and an 18. And let's see, 3. They both had a 12. That's 24. And oops, I'm not 12. That guy needs an 8, 3 and 8. 3 and 12. Let's see, 36 and 24, they both have a 4. They both have a 6, right? 4 and 6. That guy has a 9. And I think that's it. So we list all our factors. The one they have in common go in the middle in a Venn diagram. You know that. And the biggest one on the list in the middle is the greatest common factor. Would you do this all the time? Maybe, maybe not. But it is a really good visual way to line this up for kids who really aren't understanding the overlap idea here. So it's an option. It's something you put in your toolkit. Maybe you use it a lot, maybe you don't, but it's here when you need it. The third way is the one that you're going to go, what? But it works every time, which is amazing. So this is called the Euclidean algorithm, okay? You're going to make sure the numbers are positive and not equal. If they're not positive and not equal, or one or the other, it doesn't work. You're going to divide the larger number by the smaller number. If the remainder is not equal to 0, you divide the last divisor by the remainder and continue. The last divisor is the greatest common denominator. This sounds crazy, but here's how it works. So I'm going to take the smaller number and divide it into the bigger number. It really doesn't matter to keeping track of how many times 24 goes into 36, just as much as long as you get the biggest number. So I'm going to subtract. What's left is 8. Oh, no, what's not left is not 8. I'm going to go erase. My math is backwards this morning. What's left is 12. Okay. So then I take this and I divide it into here because this 12 is not a 0. So 12 into 24 goes in twice. 24 minus 24 is 0. Once I get to 0 down here, whatever number is out front that I divided by is the greatest common factor. Crazy. All right, let's do a harder Euclidean algorithm one. So we're going to find the greatest common factor of 10,764 and 2,300, okay? So we start the same way, small number, 2300, into big number, 10,764. And you're going to use your estimation skills, right? I know, let's see. 1, 2, 3. It's got to be at least 4 of them, right? 4 times 3 is 12. Yeah. So let's take 9,200 out of here because 2,300 times 4 is 9,200. I'm going to do the subtraction. I'm going to get 1,564. Here's the thing. This is not a 0, right? So I divide again. I'm going to take this number and move it to the outside and this number to the inside. So 1,564 into 2,300. That's going to be once, doesn't really matter, and I'm going to subtract. I'm going to get something left over. I'm going to get 736. And again, not a 0 yet, right? So I'm going to pull 736 to the outside and 1,564 to the inside. Okay, I would guess maybe 2 736s, right? So that's going to be 14, 36, and 36 is 72. And I'm going to subtract. All right, so I do my subtraction, I get 92. Still not a 0, so I do it again. 92 into 736. It goes at least, what, 6, 7 times. So 7, 8, 92 times 8, 6, there it is. 92 times 8 is 736. Now I am at 0. What is lovely about that is when I get to 0, whatever number was dividing by, okay, the divisor out here is the greatest common factor. So in this case, the GCD is 92. Now, that feels like a lot of work, but here's the thing. Your other option is to list all the factors of both numbers, or to do the prime factorization. And when they're big numbers, sometimes that's easy, sometimes it's hard. But this way will always work, as long as both numbers are positive and they're not equal, okay? So it feels complicated, but the more you practice it, the easier it will get. All right, let me change my slide. There is a game in here we are not going to play. I'm gonna skip it, and we're gonna move on to least common multiples. The least common multiple is the flip side of the coin. It is the smallest number that is divisible by each element in a set. So if I have the numbers 3 and 4, one of the ways to find their least common multiple is a number line. So let's count on the top by 3s, and we'll count on the top by 4s. So I'm going to make my number line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I have my number line. So here's 0, 0, 1, 2, 3. That's a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so I did 3s. Okay, I'm going to use my arrows. And then I'm going to do 4. That's 4. That's 8. That's 12. I'd go down here to 16. And what it says is the arrows will coincide on the LCM. Well, here's the first place they coincide, and that is the least common multiple of 3 and 4. It's the number that they both divide evenly into that is a multiple of both numbers. Okay? We can also do this as an intersection of sets. We list the numbers in set notation. So we list the multiples in a set rather than on a number line. So 3, 6, 9, 12, 15, 18, 21, 4, 8, 12, 16, 20, 24. And they both continue, right? Okay, and then we look. What's the smallest number they have in common that they overlap? It's 12, okay? All right, we can also, oh, it didn't change. We can also use prime factorization here, but it works a little differently. So you have to pay attention to the difference. So the first step is the same. Write the number as a product of its prime factors. So we've already done that. Let's do 36 and 24 again. So I did 9 and 4. I have 3 and 3 and 2 and 2. So I've got 2 squared times 3 squared. Okay. For 24, I've got 3 and 8 and 2 and 4 and 2 and 2. So I've got 2 cubed and a 3. Okay. So what's different is what you take for that's a 2. For a least common multiple. Because remember, when we're talking about a least common multiple, you should be getting a number that is larger than the 2 numbers you're trying to figure out. Either that or it's one of the numbers, okay? So what you're going to do is list the prime factor with the greatest exponent that appears in each prime factorization and all other factors. I'll tell you what that means in a second. So what we're going to do instead, in this time where we're finding the least common multiples, we're going to look at the numbers we have. And instead of taking the one in each pile with the lowest exponent, we're going to take the highest. So I'm going to look at my 2's. I have 2 squared and 2 cubed. I'm going to use 2 cubed. Look at my 3's. I have 3 squared and 3 to the first. I'm going to use 3 squared. So that makes 8. That makes 9. My least common multiple is 72. Now, what this idea, it says, and all other factors here. So say, for example, there was a number, we did the prime factorization, it was like 2 times 3 times 7. And this guy was 2 times 3 times 5. What you would do is you include the 7 and the 5, even though they're not in common, because it's the greatest exponent that appears in both, and everything else that's sort of lingering around, okay? All right, you'll get practice with this. It'll be okay. There is a really important theorem here. For any two non-zero whole numbers A and B, the greatest common factor of A and B times the least common multiple of A and B is the same as A times B. So if you know the numbers, you can find their greatest common factor or their least common multiple, and then you can solve an equation to find the missing one. So let's do 36 and 24. Let's see. I'm going to find their greatest common denominator first. Well, so what it says is the GCD. of these two. And the LCM times the LCM of 36 and 24 is the same as 36 times 24. Well, let's find the greatest common factor. I'm going to use prime factors. 36, 20, oops, why? Oh, sorry. Get my pen back, 36. All right, so I'm going to have 9 and 4. We should know this one by now, right? So it's 2 squared times 3 squared. 24, we should know this one by now too. 6, 4. We know it's going to turn out to be 3 to the first times 2 cubed. Okay, so the greatest common denominator, right, was the lower exponents, 3 and 2. So 3 times 2 is, or 3 times 2 squared is 12. I know that guy is 12. I'm going to write it in a different color. I don't know the least common multiple. I'm going to call that x is equal to 36 times 24. Well, 36 times 24 is 864. Now all I have to do is divide both sides by 12. 864 divided by 12. 12 goes into 86. What? Oh, I don't really want to do 12 at 86. I want to do 12. Let's see, 12. Well, let's see, it's at least 10. It's not 120. We'll use our partial products here, right? I could do 240, that would be 20. That would get me 504. I could do, you keep going, right? You get how to divide. So I know when I do all that division all the way through, I'm going to get 72. So what I know then is that the least common multiple here is 72. 864 divided by 12 got me 72. I know 12 is the greatest common denominator. Okay, so let us find this again. So, actually, I was early with the Euclidean algorithm because basically that's what we just did. So we find the greatest common denominator and we divide the product of the two numbers by the greatest common denominator. That's the least common multiple. So let's try it again. All right, so I have to find, in order for this to work, I have the two numbers I want to find the least common multiple of. But in order for this to work, I need this equation, the greatest common divisor of 731 and 952 times their LCM, I'm not going to write it out or else I'm going to run out of room, is 731 times 952. Okay. Well, let's do their greatest common denominator, 731 and 952. You can do it with the Euclidean division. You can do whatever you want. I'm going to use prime factors. So I know 731 is 17 times 43. I know 952, let's see, I could divide by 2. That would get me 476. I can divide that by, let's see, I can divide 76 by 4, so I can divide it by 4. It's 119, and that's 2 and 2. So I need more page. More page. So let's see. Over here I have 43. Oh, I did it wrong. 17 times 43. Over here I have 2 cubed times 119. Oh, 119 divides into 17 and 7, sorry. So 2 cubed times 7 times 17. All right, so the greatest common factor, right? The greatest thing that they have in common is 17. That's, you take the smallest exponent of the things that are shared. That's the only thing that's shared. It's 17. So here is going to be 17. I'm going to use a new color. LCM, I don't know. I'm going to call that X. And I know that that's going to be equal to whatever those two multiplied together is. Let's see, 731 times 952 is a big number. It's 95912. Okay, great. Now I just divide both sides by 17. And that's going to tell me that X is a really big number. It's 40,000, because a lot of 17s fit in there. 936. So that's the least common multiple of these two numbers. Now, this is a method you use when you have really big numbers and you can't figure it out off the top of your head, right? It's a perfectly reasonable least common multiple. It just means those two don't have a lot in common, right? All right, a couple last things. Oh, sorry, one more method. So when we want to find the least common multiple and we have more than two, okay, numbers, this is called division by primes. So you take as many numbers as you want, and you find the least prime that divides into at least one of the numbers. You divide where there's no remainder, and you bring down the quotient, okay? And then you repeat, and you keep going until you get prime numbers in all your spots. So let me show you what this looks like. So I'm going to list my numbers, 12, 75, and 120. I'm going to draw a line that way. All right. So I could look at my numbers. I know at least a couple of them are divisible by 2. So I'm going to divide them by 2. 12 divided by 2 is 6. 75 doesn't divide by 2, so I'm just going to carry it down. 120 divided by 2 is 60. Okay? Well, then I'm going to divide again. That's fine. How about we divide by 2 again? 2 into 6 is 3. 2 doesn't go into 75. 2 into 60 is 30. Okay? So far, so good. You know what? Maybe I'll use a 3 now. I'm going to use prime numbers. So 3 into 3 goes once. 3 does go into 75. That's 25. And 3 goes into 30. I'm left with 10. All right, I'm going to extend my line a little bit. What do I want to use next? I think I should use 5 next. So it's not going to work here. I'm not going to do anything. It's going to make a 5 here and a 2 there. All right, and then I look, and I have basically only primes left, right? So the least common multiple is going to be these numbers, these prime numbers, multiplied together. Okay, so what does that look like? Well, I have 2 times 2 times 3 times 5 times 1 times 5 times 2. That's the same as 2 cubed times 3 times 5 squared. I don't need the 1 there, right? It's 8 times 3 times 25. Oops, 25, not 24. 8 times 3 is 25. 8 times 3 is 24. 24 25s is 600. So the least common multiple of 12, 75, and 120 is 600. Okay, I didn't have to count out all the multiples. You could have, but if it was going to be something really big, we'd be here a while. All right. So there's 2 questions here at the end of the notes. The question is, do you use a least common multiple or a greatest common factor? There are 2 people jogging around a round track in the same direction. One goes completely around in 15 minutes. The other person takes 18. If they start running at the same place and the same time, how long will it take them to be together at the same place again if they continue to run? So take a second. Think about least common multiple or greatest common factor if that's what the kind of answer you want is, and then think about how to solve it. Okay, so hopefully you said to yourself, well, the time needs to be longer. So in this case, I want a least common multiple. This is a least common multiple problem. And you can solve it any way you want. For me, I think the easiest thing to do is count. 15, 30, 45, 60, 75, 90, 105. Okay, count by 15s. Count by 18s. 18, 36, 54, 72, 90. There it is. So that's an 8. The next time they're together is after they've been running for 90 minutes. And they'll be again at the same part in the track. All right, last question. Again, least common multiple, greatest common factor. A relief worker needs to divide 810 bottles of water and 324 cans of food into groups that contain the same number of items. Also, each group must contain the same type of item, bottled water or food. So you need the same number of stuff in each group. You're dividing it. So think about it. Greatest common factor, right? So in this case, I want the greatest common factor of both numbers. So you can find that any way you like. It's 810 and 324. I'm going to do prime factors again. Let's see, 2 and 405. That's divisible by 5 for sure. 5 and 81. Oh, 81 is 9 and 9. And 3 and 3. Okay, so that's 2 times 3 to the 4th times 5. All right, 324 is definitely divisible by 2. I'd get, well, I could do something different. I actually have 9 and 36 in my notes, so we'll do that so that I don't lose track of myself. 3 and 3, 6 and 6, 2 and 3, 2 and 3. So the prime factorization of 324 is 2 squared and 3 to the 4th. All right, well, let's see what's in common. I have 2's on both sides. I have 3's on both sides. I don't have 5's on both sides. I get to ignore it. The smallest exponent on a 2 is just 2 to the 1st. And they both have 3 to the 4th. So 2 times 3 to the 4th, 3 to the 4th is 162. So in each group, there's going to be 162 relief supplies. All right, that's the end of the notes for this section. From here, you have homework to do and some other things. So good luck. As you have questions, as always, please reach out. Thanks.